All right, we're gonna get into the next thing here. So, this opening thing, this one freaks you out a little bit, and this one says ratio, right? Now, but we all know that ratio means what? Ratio just means division. So the ratio of the supplement of an angle, well, supplement of an angle would be 180 minus x, to the complement, that would be 90 minus x, is 7 to 2. This is the way to go on this. I would cross multiply. 360 minus 2x equals 630 minus 7x. So I get 5x here. I get 270 there. I get x equals 54. Be careful. This says, what is the measure of the supplement of the angle? So 54 is not our answer. Our supplement would be 126. Okay. Now, hoping that this addition property stuff totally makes sense. In the diagram below, if AB is congruent to CD, do you think AC is going to be equal to BD? Of course, right? You're taking the same thing and adding it to two equal things. So if you take the same thing and add it to two equal things, then the sums would be congruent as well, right? Okay. And instead of writing this all out, this is from our reason sheet, our gold sheet number 18. Okay. And it says there, if the same, and this is true for both segments and angles, if the same segment is added to congruent segments, then the sums are congruent. Now you got to be really careful. You got to make sure you use that wording, then their sums are congruent. Don't say the sum is congruent. That says something totally different. Okay. Works for angles as well. And then it also, like you know how we did with the subs and comps, it also works if you look at the reason sheet 18b, you know, if congruent segments are added to congruent segments, then the sums are congruent. So you kind of get the same idea. And it works for subtraction as well. This is gold number 19. If the same segment is subtracted from congruent segments, the differences are congruent. You got to be careful with that that concluding reason. Okay. So I'm not going to write this all out here. It's there on your gold sheets. So make sure that you spend some time with that. Now we're going to do two. You see here it says prove A and B. We're going to do a proof. It's not two totally separate proofs. We're going to prove the A thing first, and then we're going to continue the proof and prove the B thing. So I'm going to start with, this looks exactly like a problem we did earlier a couple days ago or so. And it is, we're just going to do it differently. So I'm just marking this. I'm going to say angle ABD, comma, angle DBC are right angles. If I need to get the door if it happens and get them started. All right. If segments are perpendicular, then intersect at right angles. Now, what we did before in an earlier sheet, we then said that these angles were complementary and these angles were complementary, and then we said this was congruent to that because angles are complementary to the same angles are congruent, and that's true. And we could do that again here, but there's another method that we could do, and called the subtraction method, because we established that these two angles were right. So we could also say that angle ABD is congruent to angle DBC. If angles right angles, then congruent. And now we were given that these two angles are congruent. So if we subtract this angle from this right angle, and we subtract this angle from this right angle, we're going to be left with these congruent angles here. So angle PBD is congruent to angle WBC. And this would be what? If, this is the new thing for today, if congruent angles are subtracted from congruent angles, then the differences are congruent. And you got to say differences there. And this is gold. This is number 18B on your reason sheet. So there we just did part A. Okay. Now it goes on in part B to say that angle PBW is congruent to angle DWC. But now remember, we just said that this angle here is congruent to that angle there. And we want this whole thing congruent to that whole thing. So the result's going to share this. So if we add the same angle to two congruent angles, then the sums are congruent. So this is just one more step, actually. Angle PBW is congruent to angle DWC. This is going to be 17A on your gold sheet. If the same angle is added to congruent angles, then sums congruent. All right. Okay, so we got some more stuff here on the back. And I'm going to kind of talk through what I can. Start with step 2. I'm going to mark my diagram. NG congruent to RY, CG congruent to CR. Now, first thing, I got to be careful. I got to catch up to these tick marks. I got to say that NI is congruent to IY, and that's based on midpoint. This is on your gold sheet. This is number 9, right? If point midpoint, then divide segment into two congruent segments. Okay? Now, remember, we got to prove this big triangle and this big triangle. So we got a pair of sides right away. We got these tick marks and those tick marks, so we can use addition to get this whole side, right? CN congruent to CY. If congruent segments are added to congruent segments, then the sums, plural, are congruent. Okay? Now we're almost there. Remember, we have to say that CI, that thing in the middle, CI, that's in both triangles. It's congruent to itself, duh, of course. That's the reflexive property, but we still have to write that down. And now we have a 5-step proof. Triangle NIC congruent to triangle YIC, and this is by SSS. There's another proof here, and this proof just looks so messy because it's just so much in the given. So let's see if I can get a handle on this. This is a right angle. That's a right angle. JIL, this, and OCW is congruent. That was given to us. WOI, where's that? That's right here. It's a little bit messy. And CJL, boom. And then lastly, CO. Now we have to prove that these triangles on the right and left are congruent. Well, let's see. What do we got? Again, I want to catch up to my tick marks. They're telling me this is a right angle for a reason. So they didn't use perpendicularity. It's right angle, so that's good to know. But you see, so looking at these triangles, I have to prove I already got a pair of angles right here. I almost have a side, but I can get this side CJ congruent to OI easily just by adding this segment. You see, if this segment here is added to congruent segments, then the sums are congruent. And then I can get this angle because you see I got this right angle here and here, and I got this congruent. That means I can get this from subtraction. So let me start off by saying that the right angles are congruent. So angle WIL is congruent to angle LCW. If angles right angles, then congruent. And that gives me this angle and this angle, so angle LCJ congruent to angle WIO. If what? Congruent angles, you got to be careful with this, subtracted from congruent angles, then the differences are congruent. And again, that's the new stuff from today. Okay. This will come back. It's actually not a long proof. There's just so much in the given. So step 4. So remember, we already had these angles. We got those angles. Now we just have to get this side, CJ, congruent to OI. And that's if the same segment is added to congruent segments, then, and make sure you say sums. Don't say sum is congruent. The sums are congruent. This whole thing, CJ, is congruent to OI. And now we have triangle OWI congruent to triangle JLC. And that, of course, is by SSS. Okay. I think hopefully that's pretty good. All right. Let's see if I can quickly talk through this last one. All right. It says given angle, well, DBE has been bisected. So that means this angle is congruent. This is not a proof. This is a, so this is what? What equation can we set up? X squared plus 6 is equal to 10x minus 10. This is a quadratic. I want to set it equal to 0. I'm going to move the 10x and the 10 over. And I'm going to factor this. This is a nice, easy one to factor. 8 and 2. So we get x equals 8. We get x equals 2. Now we got to explore both those answers. Okay? To answer question A, if x is, does BF bisect angle CBA? Well, if x is 8, let's see, this is what, 64 plus 6, this is 70. This whole angle would be 90. If x is 8, this would be what, 80. This is 70 and 20. So this would be not, this whole angle would be 90 as well. So yes, if x equals 8. Now if x equals 2, this is going to be what? 10. So this whole angle is 30. If x is 2, this would be what, this upper angle would be 10. And this would be 2 times 3 is 6. 6 minus 4 is 2. This angle here, this big angle, would not be congruent to that. Okay, so, does BF bisect CBA? It might. Depends. We have two possibilities for X here. Okay. And same thing, what is true about BF and AC? They may be perpendicular. Okay. If X equals 8, then BF is perpendicular to AC. Okay, as the big angles on both sides are both 90. But if X equals 2, then BF is not perpendicular to AC, because angle ABF would equal, I think we came up with 30, and angle FBC ends up being like 12. So we can't really say anything definitive on this because we ended up with two possibilities for X, and one thing worked and one thing didn't. All right.